This can be a pretty difficult question, but the technique to solving this is always the same. So once you have learned the technique, you can solve this type of questions very easily. There are a few of such questions in the worksheet, and as I explained, you'll notice that the method is always the same. So the answer to this question is B. There are actually two methods to solving this. The first method is a shortcut method, where the length of the mirror to see the full image of the object is always half the object's height or the object's length, and therefore the answer is 0.9 meters. Now, I personally do not like this method because if I change the location where I see the mirror, the answer might not be a factor of half. This will show up in a later question in your worksheet actually. So therefore, let's learn the proper method of solving this, because this method is always the same. Therefore, method 2, the strategy is as usual, to locate the image location by using object distance equals to image distance, and then we will just draw in some ray diagram. So I have now constructed an person with a head as a circle, and he or she is standing in front of the mirror, and the first thing to do is to use the relationship of object distance equals to image distance to locate where the image is. And I've drawn in the image in dotted line, because remember, an image in a plane mirror is virtual. So after that, I will draw in a straight line from the bottom of the image, which is the foot or the feet of the person, all the way to the eyes of the person. And I will do the same thing using a yellow light ray to show how the man sees the image of the head. And now you can see that I have drawn in the incident ray and the reflected ray, and use dotted line for the light rays that is behind the mirror, because it's virtual. And now you can see that there are actually two triangles, and the first green triangle is shown, the second bigger triangle is shown in red, and these two triangles are actually similar triangles. And a property of similar triangles is that the ratio of the sides of the triangle is always the same. So if you look at this green and red triangle, if you look at the horizontal length of the triangles, the green triangle horizontal length is D, and the red triangle is much longer, so it's actually 2D as the distance. So we take the ratio of D over 2D to be 0.5. This ratio will be kept the same for similar triangles regardless of the sides. So now if we compare the base of the triangle, the green triangle, the base is X, and that is the answer that we're looking out for, because the X shows the portion of the mirror that is required for the man to see the image, and the base of the red triangle is 1.8 meters. Plug it in to equate to the same ratio of 0.5, you can then get X equals to 0.9 meters.